This does not give us anything dramatically new, but there is one thing that people make mistakes on every time. So we have in question 1 here, in practice 4, converting units of area. So we've got to convert square centimetres to square millimetres. Okay, so I'm just going to go through this one with you. What was it? 20 square centimetres is how many square millimetres? Okay, does anyone know already?
Isn't it? I was doing.
What units are they? They are metric. Metric units. Therefore, metric units are all nice and easy numbers. Times 10, 100, 1,000, whatever, yeah? That's all we've got to do. There's no times in by 2.2, 8, 1,760. None of that. It's times 10, times 100, so we just need to figure out what it is. Okay, so what is the conversion? And what would be your reasoning? First of all, will the number get larger or smaller? Yeah. There'll be more square millimetres than there are square centimetres. Okay? So we are going to have to do 20 multiplied by something. So I guess we should start with this fact, which is if we have a number of centimetres, how do we get a number of millimetres, so a length? What do you multiply
By 10.
By 10. Okay. So what if we've got square centimetres and we need to have square millimetres? We multiply by square. Just to keep this simple now, if you have cubic centimetres for volume and you want to convert that into cubic millimetres, you times by 10 cubed. Yeah, that's simple as it. One-dimensional, area is two-dimensional, volume is three-dimensional. Therefore, everything is multiplied or raised to the power of whatever dimension you are doing. Okay? So, how many do we have? Well, it's going to be 20 times 10 squared, which is 20 times 100, which is 2,000 square millimetres. Okay. Make sense? So all we've got to do is remember. Now I'm not focusing in on how do I remember how many centimetres and millimetres that can, because we've done that. You've got using the prefixes for that. Whatever method you have come about to be able to work out the one-dimensional stuff, remember that, and then just go, but I'm doing 2 dimensions or I'm doing 3 dimensions and so on. Okay, let's just have a look at another one. So let's do 5,000 centimetres squared to metres squared. So 5,000 square centimetres into square metres. First of all, is the number going to be larger or smaller? Smaller number. That should be the first thing that goes on in your head. Am I expecting a larger or smaller number? Larger unit, smaller number. All right. So, centimetres converted to metres is? So centimetres, yeah, is metres times 10 to the power of -2. Okay? So normally we would do times 10 to the -2. So the centi bit means that. Therefore, square centimetres to square metres is times 10 to the negative 2 squared. And what's 10 to the negative 2 squared? Times 10 to the, remember your laws for exponents, minus 4. And let's just confirm that, maybe putting it in a way you understand a bit better. Timesing by 10 to the negative 2 is the same thing as 10 to the power of, which is dividing by 100. This would be dividing by 10 to the power of 4, which is the same thing as dividing by 10,000. Yeah? So we are going to divide by 10,000 or divide by 10 to the power of 4, which I think makes more sense because now we take each number and move it 4 place value columns down the value system. So the 5 moves 1, 2, 3, 4. So we actually end up at 0.5 square meters. Now, if I understand what I said there.
Yes. Wait, why did you put the times 10 to the power number to accurate so you square?
Because, well, I have to take that number and square it.
Why is this? Oh, because it's meters squared.
Yeah, because it's area. So remember, the times 10 to the negative 2 is the length version. Yeah, centi means times 10 to the negative 2. But square centimetres, now, I often think it confuses people a little bit if you say centimetres squared. Although that's kind of what we're doing, it's square centimetres. And that makes sense to me. The centi is also squared. And how do you square something?
You multiply it by itself.
Yeah. So this here would be times 10 to the power of negative 2 times 10 to the power of negative 2, which is the same thing as timesing by 10 to the power of negative 4. Yeah. That's your laws of exponents that we did previously. One other one then, let's look at these volume one. All right, 40 cubic meters into cubic centimeters. I hope I'm giving you long enough time, by the way, to write it. Trying to talk while you're writing down. What did I say? 40 cubic meters into cubic centimeters. So I'm going to do the same thing again. I'm going to write, well, meters to centimeters. Well, if it was that way, it would be times 10 to the negative 2. So we're going the opposite way. So it's times 10 to the power of 2. We're doing the opposite way. Remember that? Makes sense, right? Times 100. How many centimeters in 1 meter? Times 100. So we should be getting a bigger number because we're going to a smaller unit. Makes sense? Therefore, if we're looking at cubic meters, we're actually, and we want cubic centimeters, we're going to have a lot of more, aren't we? If you think about it, guys,
Big one.
yeah, I kind of visualize this for you. It's quite difficult to hold it all go, but this might make you or help you comprehend why there's so many of them. All right, how many centimeters in a meter? 100. So if I talk 2 dimensions, imagine, all right, that I take that and that. So every little square is now counted. So it's 100 by 100 square centimeters, right? Makes sense, there's a lot of them. Now imagine that up in that direction as well, that's a cubic meter. How many of them are there? 100 by 100 by 100. Lots, right? And you can see the amount of space. That's why it makes sense that there's a lot of them, right? So therefore, I often draw that, and it's not so easy to visualize it through just drawing it. But we're going to times by 10 to the power of 2, but cube, because you've got the 3 directions. All right? That means times 10 to the power of 6. Good. So we're going to do 40 times 10 to the power of 6 cubic centimetres, which is also 40 with 60, so 40 million. So 1 cubic metre that I just showed you, 1 cubic metre, if I just hold that like that, basically in my hand I've got 1,000,000 cubic centimetres. There's 1,000,000 in that space. Almost doesn't seem possible, but it is. Okay, and then hopefully, is this all making relative sense? The big thing is, if you've learnt your conversions in 1 dimension, then you've learnt them for 3 dimensions. All right. How many cubic centimetres? No, sorry. How many 4th dimensional centimetres would be in a 4th dimensional metre? So 10 squared to the power of 4. And then you've got to think, well, what does that look like? We don't know because that's 3 dimensional. Yeah. The one next thing, one extra little thing here that I put on there, which is in your textbook. Volume is generally measured in cubic centimetres. However, capacity is. What's the difference between capacity and volume again?
Oh, capacity is yeah. Wait, what?
You kind of so what things do we tend to measure in litres? Liquids quite often.
Capacity is the amount of space available to hold something, and volume is the amount of space off.
That's a good answer. So anything that is being used to hold something, basically, said Jackson, we can say that is its capacity. Now, normally, what do we hold in things like that? Liquids, because they fill the space. Gas, yeah, all that kind of stuff. So normally those. Now you had your. Some of you had your shoe boxes from your homework listed as litres or centilitres, didn't you? Because of capacity, right? However you came up with that answer was up to you. But there is generally sort of using, like ice cream tubs are measured in litres, gallons, that kind of stuff, because it is a liquid, therefore we do it.
But that's a solid.
Frozen them. Okay, so you've got there a conversion that helps you. So 1 cubic centimetre is basically a milliliter. Therefore, 1 litre, I always think you get 1 litre bottles of drink and stuff, but 1 litre is 1,000 cubic centimetres. Back down, you mean?
Down.
Right, so that's a piece of information. Just when I put the notes back up, you guys are going to be on practice 4 lick. I don't want to spend too long because you've got that to do. Page 231 to finish off those calculations. Our next step, okay, Well, you've got these ones as well. That introduces some other. Obviously, you've got that to do. And then our next thing is the compound measures. That's what we'll do tomorrow. So you've got plenty of things there to work on today. All right, I'll put those notes back on board. Okay, go.
Are we gonna be able to review our notes on